So this is the last use case, predictive maintenance. Why this is useful is, let's say you have a motor. Now we are used to of seeing motors in our household. It's not economically very useful to know whether your hair dryer is going to stop working, next day or next month or next week, because you can always groom yourself without that. It's not a critical application as such. It has a motor, and there are a lot of other appliances that have motor. For example, the refrigerator, which is one of the critical household appliances. If your refrigerator sort of stops working, then your food will go waste and will start to go bad, and you can't eat that food. And you would need a new refrigerator in few days. So it's kind of that criticality. And let me give you an example of that criticality in the industry. So there are these very, very large machines. For example, take an example of our customer, which is producing fabric in southern India, and they have over 50 acres of the factory, and they are very large pumps and motors on that factory. And to give you the economic loss, if they lose one motor or one pump for 5 days, they are losing 3 million Indian rupees every day. So why that is important to bring here? Because you want to know if your motor is going to stop working 3 days from now or would have some difficulty 5 days from now. So that prediction is very important for those companies to continue running and producing the goods and services that they are supposed to produce. So if you can give them a solution that tells them that, hey, your machine is going to go bad 7 days from now, because I know the harmonics of this machine, the vibration pattern of this machine does not look right. It's not healthy. What the person, the floor manager or the engineer can do is to call the manufacturer of that motor or pump and say, hey, something is wrong. Why don't you send your technician? Technician comes in 3 days and says, okay, yeah, this is bad. I'm going to change this component and it's going to be good. So, and doing that, they save millions and millions of dollars in their business, and that's why it's critical. And now, how many industries are there? The answer to that is how many motors and pumps are there. This planet is flooded with motors and pumps in practically every industry. There won't be any single industry that does not have motors and pumps. So with that, let's watch this quick 2-minute video, and then we'll continue talking about it.
Condition monitoring increases production capacity, motors lifespan, and businesses top line. Monitor your money-making assets like motors, pumps, molding machines, and so on by predicting faults like unbalance, misalignment, bearing issues, and so on before they happen. Traditionally, predictive maintenance solution relies on Wi-Fi, cloud, internet, remote servers, and electricity. Our solution requires none of these. The solution consists of a sensor board and a mobile tablet. Sensor board is attached to the motor. Sensor data from the motor is captured on mobile tablet using BLE or USB. With touch buttons, capture data is compiled into an AI model customized for the motor. The AI application is downloaded from sensor board. Sensor board is then left running on batteries connected to motor for up to a year. Entire end-to-end solution is trained and deployed in austere environments with no electricity, no cloud, no internet, and in the stealth mode with absolute privacy and security.
So we're going to move on from this.